Okay, we're live, and hello everyone. Welcome to our RavenDB Discord event. I'm Alexander, developer advocate at RavenDB, and I'll announce this event today. This Discord server is quite new, and we're just getting started here. Our goal is to make this place where developers, database experts, and RavenDB users can learn, share knowledge, and connect with RavenDB team. And if you have any question, idea, or want to discuss anything related to RavenDB, this is the right place to be. So before we begin, I want to thank the people who help make this event possible, Micha, Gracian, and the entire RavenDB team. Their effort is something that help setting up this session and allow us to be here today. So today's topic will be search in RavenDB. Finding data efficiently is a key part of any database system, and RavenDB provides several ways to do it. And today we will start with basic search, then move through some advanced techniques like fuzzy search and full text search. And after that, we will dive into vector search, which enables AI-powered and semantic queries. So our presenter today is Dejan, head of DevRel at RavenDB. Dejan has a superpower to explain complex topics in a way that is clear and easy to understand. So if you ever struggle with the search concept, you're at the right place, and now you will understand it better. So without further ado, let's get started. And Dejan, the floor is yours.
Thank you. And if I remember correctly, we are also streaming this on YouTube. If you can share the URL on the Discord.
Yes.
Okay, so during next 50-something minutes, I'll try to introduce you to vector search and the mechanisms behind it. If you have any questions, feel free to type into the chat and Alex will read them to me, or I think you can also turn on the mic and speak. So let me start with a simple question. If I go to Amazon.com and if I look at this product, how is this part here implemented? Probably not manually. There's some kind of algorithm behind it. Usually on websites like these, you have recommended products or related videos. And you can already imagine when you try to think about how to implement something this complex as Amazon.com, you can already guess there's lots of automation. Also, if you ever worked with e-commerce websites, you probably are aware that sometimes these bestsellers or recommendations are actually the opposite. So sometimes smaller e-commerce websites will intentionally put down here things which are not selling good. But let's imagine we are tasked with implementation of similar products related to the one I'm looking at. The million-dollar question is how to implement it. And today I'm going to demonstrate a couple of things with RavenDB. I'm running locally RavenDB on my machine, but everything I'm showcasing today, you can try it on your own. You don't have to install anything, just go to live-test.ravendb.net. Alex, if you can share this link, I'll be grateful. So everything I'm showing today is available on all platforms. If you're running natively, if you're running from Docker, if you visit live test, if you go to our cloud. So I prepare some materials. We will share it with you afterwards. So let me create a new empty database. All right. It's completely empty. Control K will bring me to a panel where I could do some quick searching of the features, create sample data. I'm seeding a database with some data. here are the collections. And if you ever worked with any of Microsoft products, when you start digging into this data set, you will immediately recognize a Northwind database. So what you're looking at here is a small scale version of Amazon.com. This is Northwind, imaginary company that is doing food trading. And now the question is, what we have here, products, how to work with them from the perspective of a database. So simplest possible query is something like this. Listing all the products that we have in this database. I can also go and order them by name. So now you can see in ascending order, all of the products are sorted. Here is tofu, for example. So let me try very naive, very primitive elementary search mechanism. Exact search. So I executed this and RavenDB filtered out all the product that has exactly this name. So this is exact match. Of course, what happened behind the scene is not so simple. So what you can see here is a Raven Studio is giving me information about which index was used. What happened when I ran this query for the first time is that RavenDB recognized that I'm attempting to execute something that might be expensive. So filtering out products by the name, in case you have like hundreds of thousands of products, can be very, very expensive. And it is becoming even more expensive as database grows. So RavenDB engine stepped in and created this automatic index. Of course, after that's completed, results are returned to me. And now every time I run either filtering or sorting on this field, results are coming from the index. This is guaranteeing that things will be fast. Okay, so I got my product with the name of tofu, but imagine now if something different with the tofu in the name exists, it's invisible to me. There's something called fuzzy search. Fuzzy search would provide a way for me to search for similarly looking names. So let's say I have a typo or I have a name that is similar. I can use fuzzy search to find names which are similar. And I attempted to execute it and I got an error. The reason for this is in version 7, I'm running under developer license. And developer license is prioritizing one of two indexing engines. So inside of RavenDB, you have, in version 7, you have two indexing engines. One is Lucene.net, and the other one is Corax. Corax is, you probably heard about Lucene and Lucene.net. Lucene is in the heart of solutions like Solar and Elasticsearch. And Corax is our own in-house search engine that we released 2 years ago. And overall, it's superior to Lucene, well, with the exception of the fuzzy search. So, for example, how to solve this problem? Because if you look at the indexes, you can see that this index is Corax index. This is automatic index that was created when I executed my first query. So how to solve this problem? Well, I can go and do following thing. I just opened definition of this automatic index, and I'm going here and requesting conversion to static index. So this is something we introduced recently. This is ability to take automatic index and request to RavenDB to produce static index based on this automatic index. So what I have here now is the equivalent as if I coded it manually. It would be great if you start using this and report back to us how it works for you. And here in the configuration, I can pick up Lucene as the indexing engine. So this would be one way to solve this. As you can see, this index is now a Lucene-based index, so I can combine in the same database indexes that are running on Corax indexing engine and indexes running on Lucene indexing engine. But there's one more possibility. If I go into database settings, and today it takes a bit longer for this page to load than usually. Alex, in the meantime, if there's any questions, you will let me know. There are two settings that you can tweak. Here are the names. So this would be search, this would be for automatic indexing. This would be indexing engine used, and this one is for static indexes. So what I can do, I can locate setting for the auto indexes. Here it is. And I can override this, mandating this is Lucene. I'm saving new settings. And before it becomes effective, I need to either restart my database or I need to restart whole server. Of course, if I restart whole server, it will be, especially in production, it will be time consuming. So I will restart this database as soon as my browser comes alive. So you can see in the settings, items which were modified are appearing in yellow. So here is how I can restart my database. It should be a brief process. And from now on, I have a new default indexing engine set as Lucene. So I'm deleting automatic index. And if I go and repeat my original fuzzy search query, I will get back my results. Fuzzy search is not doing anything spectacular. It will, simply speaking, compute metrics, number of permutations between two terms. Like if you take this one, and if I take tofu, you can see how many permutations or modifications are needed to go from this one to this one. Well, these two middle letters are reversed and I'm arriving at the tofu. So you could say that matrix or distance between these two terms is 1. Of course, this setting here is the, let's say, sensitivity. So it is mandating how far I can go from my original term. So you can see, you can get interesting results. All right, so as you can see, I'm already performing something more advanced. I'm finding things which are similar, but of course, this is just comparison of the letters. Of course, I'm aiming here to find everything that is chocolate, and here I'm having a Indian tea. So semantics is not present here yet, just syntax. Next thing I can do with RavenDB would be prefix and postfix search. So this will provide results by the prefix, as you can see. And again, I'm having just one product that starts with tofu. But if I go with ends with, here it is. Here is the first benefit that I have from advanced search features. I just discovered that I have 2 types of tofu in my offering. And finally, further we can go with the classical approach. Classical search techniques is full text search. Again, I executed this and I got results, and this is rather good. What was happening behind the scene is not so simple anymore. So full text search is approximate search, or let's say partial matching. So as you can see here, I got both of these products as a result, even though for the second one, tofu is in the second place. So what was happening behind the scene when I executed this query is, again, RavenDB reacted and it created the index automatically. Here it is. And it did something interesting. All these product names, as you can see, are consisting of multiple words. So RavenDB used a Lucene mechanism, and later on in Corax, we are using the same mechanism of tokenizing these product names. So what happened behind the scene? Product name like this one was splitted into 4 entries. You can find them here. So internally, when I go and execute something like this, tofu, which is partial matching, RavenDB internally will execute something like this, where name equals tofu, sorry, search of name. So again, add the index. So what you can see here, what is the content of this index, is that for every product, which is denoted with product ID, we have entries. So for example, you can see here, product with the name chai, entry in index is also single word that name consists of. But if we look at this one, you can see what is happening. Composite name that consists of multiple words was splitted into 2 individual words. So now when I go and search for any of these individual words, I will get this product as a result. For really, really long product names, you can see this one materialized into 4 index entries. And this is also nice. Full text search is nice because I can go and use different operators like wildcards. So now everything that starts with TO in any of the words will be returned back to me. Now, all these techniques are, let's call them classical techniques that exist for multiple decades now, and they are providing good results. But all of these matchings are achieved on not on semantics of the word, but on the syntax. So similar letters and similar words are being compared together. And the database with all of these techniques is completely unaware what is the content. So you saw it a moment ago. I was looking for a chocolate and I was getting let me try this one. CH. So I'm getting here tea and a chocolate and various things. Okay, before I proceed with 21st century research techniques, any questions, Alex?
No, not for now.
Okay, so everything is crystal clear. So how to cross over to 21st century? Well, in version 7, RavenDB introduced something called vector search. And this is quite an intuitive name, vectors, but result is, let's say, close to spectacular. So what I'm doing here, again, I'm searching over products, and I'm using vector search to find everything that is Italian food. And you can see, and I limited to 3 top most results, 3 best results. And what you can see here is something interesting. I was searching for Italian food. I got three products, first three products. None of them contain either Italian or food in the product name. And if you look at actual products that were returned back to me, this is mozzarella, Italian cheese, this is ravioli, Italian pastry, and Chef Anton's gumbo mix, probably also something, we don't have a recipe here, of course, but also probably something that is Italian. If I look at something like candy, I'm getting chocolate biscuits, chocolate, and syrup. Again, I'm getting back results which are meaningful. Even though none of these products contain a word candy in the product name, I'm getting them back. And for me, first time I saw it, it was quite impressive. And now we have it in RavenDB. And now in the second part of this event, I will try to explain to you what is actually happening behind the scene, how this, let's call it magic, works. So first step is when I started playing with this, I wanted to run all of these large language models and text embedding models locally. And here is the nice application you can install yourself. It's called LM Studio. We will share the links after this event in the Discord. So LM Studio provides way for you to run, download, install, and run these models locally. Before this event, I downloaded and installed DeepSeek. You probably heard about it. DeepSeek is large language model. And in LM Studio, you can actually use it locally, so you can go and chat with it in a similar way, like you're chatting with ChatGPT. So I can go and ask, what is the capital of France? You can see the result, and I can go and say, okay, what are...
We cannot see it.
You cannot see Studio.
No, we are still seeing the RavenDB.
Oh,
okay,
it's probably a bit
delayed or something, maybe. Huh?
Can you see it now, or
yes?
shall I restart?
Now we can see it.
Okay. So this is LM Studio. You can download and install models inside of LM Studio. And then you can, for example, use them locally. So here I'm using DeepSeek R1, and I can go and check what I should go and see in Paris. And you can see it thinking. And even though my machine is not too powerful, DeepSeek is, let's say, a bit optimized and lightweight. So as you can see, it's not super fast on normal machines, but it's working definitely. So this would be one of the solutions where ChatGPT is down. Okay, so we are all playing with these large language models. And large language models are essentially rather simple things. They are simply completion mechanisms. What is especially nice is that LM Studio is providing a way for you to use these models programmatically. So if you go here into developer section of LM Studio, you can see that I have here my model loaded. And down here, you can see 4 endpoints that LM Studio is exposing. Now, it says here OpenAI-like. A reason for this is that OpenAI came out early, something like 5 to 6 years ago. They offered these endpoints with the remark that this one is deprecated. And over time, these now 3 endpoints became some kind of standard, de facto standard. So for example, if you look at some other large language models and their services, they will also offer these endpoints. So I can hit it programmatically. I'm using Visual Studio Code and REST client extension, so I can make a call to this endpoint, which will return to me a list of models that my installation of LM Studio has downloaded and installed. And I can go and I request completion of this sentence. So when you go and when you chat with ChatGPT and other large language models, they will modify your output a bit, and they are essentially completing current stream. So when I send this sentence as a content to the completion endpoint, DeepSeek will search for most probable next word that will appear. So you can see here is the content that was returned back to me. This is special token. You can ignore it for now. And this is actual response that we were also able to see here in the LM Studio directly. So this is nice because now you can programmatically develop AI-powered applications on your machine. This is LLMs, one of LLMs, and you could say that they are quite heavy. They're quite heavy, they are resource hungry, and you will need at least some kind of decent graphic card to be able to run it on your machine locally. Vector search is not using LLMs. Vector search is using something called textual embedding model. Here in LM Studio, I downloaded this model, text embedding BG Micro V2. This is one of the smaller models. It's very fast. It's, let's say, some kind of very good balance between accuracy and size and speed, of course. So how you work programmatically with text embedding models. Here I have, or better, let's go with pizza. So here I have an example. I will call this, I will perform post call to this URL. I will pass on input, which is pizza, and I'm also stating here the model that will be used. And as you can see, waiting, after a second or two, I got back something rather interesting. Vector search is based on the embeddings, and embeddings is nothing more than an array of numbers. But in my case, you can see that this array of numbers is pretty big. So what I have here with BG Micro V2, what I got back, BG Micro V2, I have 384 numbers like these. If you look closely, you will notice that these are numbers which are between -1 and +1. So why 348? Well, actually, this is number of dimensions. So what I'm getting back is called embedding, and 384 is dimensions. So what I'm getting back is vector in 384 dimensional space. If this was three-dimensional space, response from this text embedding model would look like this. We all know this. These are 3 coordinates in Euclidean space, but these 3 numbers would not be good enough, would not be precise enough as description for the term that I generated embeddings for, and this was pizza. So you could say that text embedding model is using these 384 numbers to numerically describe word pizza. and it goes on and on. I can provide other terms like mozzarella, and I can send requests, and you saw the blink, these numbers changed. And I can also request it for Italian food. Every time I send not just one word, I can send a sentence or a phrase, BG micro v2 will return back to me an array of 384 numbers. These are translated to mathematical terms, these are vectors, starting from 0, 0, 0, 0, 0 of the coordinate space and pointing to certain point in 384 dimensional space. This set of numbers is carrying meaning. So now we will be able to compare meaning of these words because we translated these sentences and words and phrases to numbers, and now we can work with numbers and we can compare them. So how to compare? Well, we can use a well-known mathematical apparatus for this. We can use cosine similarity. Here it is. Here I'm using a Python function. This is purely mathematical function for computing similarity between two vectors. And here is my implementation. So what I did, I computed embedding for phrase Italian food. I computed embedding for mozzarella. You saw this a moment ago. Here is embedding for pizza. And here is something that is not Italian food. This is tofu, Japanese food. But let's see what will be numerical results for all these things. So what I'm doing here, I'm calling cosine similarity for embeddings for Italian food and for mozzarella. Again, Italian food and pizza, and Italian food and tofu. I'm computing first similarity, and then I'm computing distance, which is 1 minus similarity. And here are the results down here. So what you can see here is first similarity and then a distance. What is nice is that cosine similarity will always return number between 0 and 1. And this is important because these numbers or these similarity or distance results are normalized, and we can compare them and we can rank them. So if you look at these numbers, you can see this would be highest similarity. So of all these three foods, pizza is closest to semantical meaning of Italian food. And you could say this is 69%, because this is number between 0 and 1. We can also treat this as percent. So this is 69% similarity to Italian food. And the second one is pizza, 0.51. And finally, we have tofu. It's 0.44. And you can already see tofu is below 50% of probability of being Italian food, which is nice because we can eliminate, for example, everything that is below 50% of similarity. And now when you look at distance, this is what we are essentially looking for. We are looking for the results with lowest distance. When you have low distance, these two things are closed. So we can proclaim in this result set that pizza is the most Italian food in our food offering. Now, when you look at this model, we can debate if these numbers are good enough or not good enough. Well, now we are entering the realm of text embedding models, how precise they are. And of course, I already mentioned, if we would want to use 3 numerical values to describe pizza, you can imagine that accuracy of such description would be low. If we cross to something like this 384 numbers, accuracy will be larger. Accuracy will be better. If we go to even larger models, accuracy will be even better. And it's always a matter of juggling between the resources you would use and the accuracy you need. Sometimes you will need something very specific, and then you will reach for better models. But I think this is doing the job. So this is what happens inside of RavenDB. And the model I use today, text embedding BGE micro v2, is now embedded inside of RavenDB. So all of this process that I described, and let's again recapitulate what I did a moment ago. So what I did, I picked up few words, few phrases. I called embeddings, and I got back these 384 dimensional vectors. And then I reached for the vector cosine similarity and computed and compared. All of that is needed to implement vector search. And the good news is that all of this is happening automatically inside of RavenDB. So when I called it, I use vector.search. And what I'm doing here, I'm requesting from RavenDB to compute embedding for product name. So literally, RavenDB will take all these product names, and it will call BGE micro v2 that is now built inside of RavenDB, and it will get back these 384 long array of numbers, and it will store them in separate storage. And then all of that will be stored inside of the index. Okay. What will happen next? RavenDB will take word candy, compute embeddings for it as well, and then it will compare it with the rest of the embeddings stored inside of a special area of index storage. What is interesting is the algorithm that is used to perform this comparison, and this would be the algorithm. It's called HNSW, Hierarchical Navigable Small World. This is a clever way to find nearest, approximate near neighbors for the vector that we are searching. When you start thinking about it, in a database of thousands and thousands and thousands of products, we will end up with thousands and thousands of vectors. We need a way to compare all of them in reasonable amount of time. And this is a rather accurate algorithm, which is not too heavy on the CPU, that will find precisely what we are looking for. What is important to understand is that if you look at this visualization, the yellow one is the query vector computed for the term that we are seeking for. This would be candy. And all of these others would be embeddings computed for product names that exist in the database. So our goal is to find a nearest neighbor. Almost never we will have exact matching. It's just a matter of finding neighbor which is closer or closest or closer and return back. Again, we will share all of these links so you have opportunity to look at implementation details yourself. So all of this is happening automatically, and for me personally, the best part is I first started using this. I was clueless what is going on behind the scene, and I did not have to know anything. And later on, I dig into implementation and learned all of these implementation details. So this is nice, nice way for you to start using AI without being forced to learn about all these details. Alex, do we have any questions?
Yes, sorry. Okay. Grazian asks us, what do you guys think? Should vector search be implemented in every modern database? Or is there a market for vector specialized database too?
Yes and yes. So when you look at the landscape of modern databases, you have specialized databases and you have general purpose databases. So in this case, as it is with some other areas like graph, for example, you have graph databases, which are specialized. You have general purpose databases like RavenDB, where you can implement the same thing. Same thing goes with vector search and AI. So you have indeed specialized databases, like I think this is on the Pinecone website. So this would be an example of specialized database. But what is interesting is that if you need to implement a single feature, and we started with this, we started with find similar products, or people who purchased mousepad also looked at these things, for example. Now imagine amount of effort that you might need. So will you go and download Pinecone, install it, load all of your products into the Pinecone, set up ETL to keep this second database updated, and then finally implement a single REST API that would talk to Pinecone? Well, you can, but it's significant effort. On the other hand, if you're using like general purpose database with a feature like this one, you would be able to use it in no time. So this is all it takes for you to start using vector search. Just write your query either here or in programming language of your choice using RavenDB client API, and you will get back meaningful semantic search results. So I think there's space for both of these categories of databases when it comes to AI. You have general purpose databases with AI capabilities, and then of course you have specialized ones for specific tasks. But if you think at where we should start reasoning from is a problem that we need to solve, and something like this would be problem we need to solve. Then you will probably, as all good developers are seeking for, simplest way to solve the challenge you have.
Okay, I think you answered quite details to this question. And I can see that Mufasa commented that Team Topologies is an awesome book and great recommendation. And
it is. I agree. And for example, this would be one of 3 best books if you're interested in databases and designing applications that are working with large amount of data. Now we have like 10 more minutes to go, and I just would like to give you a hint of the things that will come soon. So in next 5 to 10 days, maybe sooner, we will release extension to this. So what you saw me doing today, I was executing vector search, and RavenDB was using its own built-in text embedding model, BG Micro V2. Of course, this is not the best. This is one of these models. In next version 7.0.1, RavenDB will offer AI ETL. So what will happen with AI ETL? Well, you will have an opportunity to take your document from a RavenDB database, and then using AI ETL, you would be able to push it to external LLM, which will take the document or some of the fields of this document. LLM will compute embeddings, and then these embeddings will be returned to RavenDB and stored. So if you need something quick and easy, you can use BG Micro V2. If you have a serious challenge to come up with very accurate embeddings, for example, more dimensions than this one, you can use any external, you will be able to use any external LLM and push your documents, and LLM will compute. To be more precise, this should be text embedding model, and it will return back embeddings for these documents, and they will be stored in RavenDB. And then after that, you will be able to execute same type of search, but now this search will be much more accurate, which is of course important. This is coming soon, and something we are currently working on. Next big thing, I think we can announce it on the next live event that we will have.
Okay, before we end, there is one more question, and it's quite interesting, coming from the wizard. And he asked, what if the underlying model does not match my data very good? Any way to train it or replace it?
Yes. So what you saw me doing, and the reason I limited, not the reason I limited, but if I remove limitations, and now you can see that BG Micro V2 is not the best text embedding model in the world, because if you look at these results here, here is tofu. And tofu is not sweet, well, and this is what, a sixth result. The reason for this, again, is the nature of artificial intelligence in general. These are probabilities. This is not binary. This is, if you think about it, we are all angry with ChatGPT when it's hallucinating, but when we do it, we're not angry at each other. Well, AI, you could say that AI is also starting to, in a way, replicate human behavior when it comes to, guessing and the probabilities and the errors. So in this case, I would dare to say that if I'm going to pick up 3 or 4 recommendations, BG Micro V2 would be good enough. But if I want to present what we have here with the Amazon, 6, 7, or maybe 10 of these products, I would run into maybe unpleasant situation that, I would present something like this as a recommendation. In that case, if BG Micro V2 is not accurate enough, I would go with this option. AI ETL, which is coming in a couple of days, where you will be able to take documents from RavenDB, send them to a REST API like this one, and behind this REST API can be OpenAI's one or DeepSeek or whatever you might train yourself, and get back embeddings that will be having as many dimensions as you need, and it's more accurate, and then you will be able to provide results which are much, much more accurate. So when you look at it, we are providing fast and easy, effortless way for you to start. This can be used to build MVP of your product. And then if you want to go with more accuracy or specifically trained text embedding model, you can train it yourself, you can expose it to REST API, and then set up easily within a couple of minutes a RavenDB AI ETL that would be pushing to external one. I hope that's a detailed enough answer, but if I was not clear enough, please do say.
Yes, I think you were. So, okay, guys, any more question? I don't see it coming, so I think we can call it today. Then with this event.
Okay, I would like to invite you to try this out, to talk to us on Discord. Join our Discord if you're not yet a member. Try these things out. Let us know what you think, how you like it, or what could be better. We would like you to be driving this product. So we are eager to hear back from you and implement things you would find helpful.
Okay, I think that's it.
Okay. See you next time.
We'll leave. Bye.